All right, today we're going to take a look at KrystalFrame, a Java framework that asks a pretty interesting question. What if you were the one calling all the shots with no hidden magic involved? Let's dive into its really unique way of building back-end applications.
So let me ask you this. As a developer, you ever found yourself completely lost in a sea of annotations and all that framework magic, where you're not really sure how all the pieces are actually wired together? Well, KrystalFrame was pretty much born out of that exact feeling, aiming to put clarity and direct control right back into your hands.
And this slide, it just lays it all out, right? On the left, you've got that magic box approach that a lot of big frameworks use, hiding all the complexity behind tons of annotations. But on the right, you see the KrystalFrame philosophy. It's like, here are the Lego bricks. You build the castle. It's designed from the ground up to be lightweight, explicit, and give you direct programmatic control instead of hiding how things really work. Okay, so to really get a feel for this philosophy, let's actually follow the journey of building a simple API. And of course, we're going to start right where every single application begins, inside the main method. What's really cool here is just how clear the startup process is. This little snippet from our main Java file shows a direct, super readable sequence of events. You set up some components, you start the server, and then you call this one final crucial line, flows.core.await 0. So what in the world is that last line doing? Well, that await call, that's the magic of flow control, which is basically the heartbeat of the entire application. It uses a Java concurrency tool called a phaser to manage all the startup tasks. And most importantly, it keeps that main thread alive, making sure your server actually stays running and can listen for requests. And, while your app is just chugging along, the framework gives you a couple of really handy tools to interact with it. Commander lets you fire off commands from the console for runtime management, and Console gives you some simple tools for things like progress bars, right there in your terminal. Okay, so our app's alive. It's running. Now what? Well, it needs to actually listen to the outside world, right? It's time to handle some incoming requests from the web. For that, KrystalFrame gives us the Crystal Servlet. Now, this is a modern asynchronous builder that takes advantage of Java's new virtual threads for some serious performance. And here's the kicker. You are the one defining everything programmatically. There's no slow, annoying class path scanning for annotations when you start up. Nope, you build the behavior you want explicitly. And you can see that approach right here. It's like building with blocks. Instead of throwing annotations all over your code, you just build your servlet. You define your post logic, your delete logic, and snap them all together. It's clean, it's readable, and it's all in one spot. All right, now we get to what I think is the real heart of the framework. Its persistence engine. This is where the magic, well, the non-magic happens, turning your plain Java objects into database records with almost zero friction. So just look at this option class from the example code. At first glance, it's just a simple POJO, right? A plain old Java object. A couple of fields, nothing fancy. But a few small, very deliberate tweaks are about to turn it into something way more powerful. And it happens in just 3 dead simple steps. Check this out. First, you implement the entity interface. That's like raising your hand and telling the framework, hey, I want to be saved to the database. Second, you slap on an @table annotation to tell it which table to use. And third, @key points out the primary key. Boom. Done. Your simple little object is now ready for the database. And I gotta share this. While I was digging through the source code for the core persistence interface, I stumbled upon this gem of a Java comment. It's just perfect. It's such a great reminder that this isn't some stuffy corporate framework. It's built by real developers for real developers. So that persistence interface we were just laughing about, it's actually the linchpin of this whole data system. Just by implementing it, your class instantly inherits all the standard CRUD methods. Load, save, delete, they're all there, right out of the box. You don't have to write a single line of boilerplate code for them. But wait, there's more. For performance, KrystalFrame has this built-in caching layer called persistence memory. And using it is almost ridiculously easy. You just add one annotation, @memorized to your entity, and bam, the framework starts caching those objects in memory for you, slashing the number of times you have to hit the database. Okay, but what if you need to do something more complex than just loading by ID? That's a common scenario, right? For that, you've got persistence filters. It's this really slick, type-safe builder that lets you create your where clauses programmatically. You can filter, sort, limit your data, all without writing a single drop of raw SQL. But what if you want to write raw SQL? What if you need that raw power? Well, true to its no magic philosophy, CrystalFrame gives you an escape hatch. The Query Factory is the low-level engine running underneath everything. It lets you get your hands dirty, defining your own database providers, specifying JDBC drivers, and building raw SQL statements. So you always have that final level of control if you need it.
So, okay, we've seen all these pieces. How does this whole philosophy stack up against, say, a behemoth like the Spring Framework? And look, this isn't about which one's better. It's about different tools for different jobs, different philosophies for solving the same problems.
And this table here really breaks it down. With CrystalFrame, your configuration is all programmatic. It's explicit. You write the code. With Spring, it's declarative. You use annotations like @rest controller, and the framework figures it out. For the web layer, CrystalFrame gives you direct servlet control, while Spring abstracts that away with its whole MVC pattern. And for data, it's CrystalFrame's super lightweight entity interface versus Spring's massive JPA and repository system. See the difference? Direct control versus abstraction. This really fundamental difference in philosophy brings up a huge question for how we build apps today. Where does a framework like this actually fit into the modern world? Well, to help you think about that, let me throw one more number at you. The entire core library for CrystalFrame is less than 1 megabyte. Let that sink in. In a world of Docker containers and microservices where every megabyte counts, that is kind of a huge deal. So I'll just leave you with this final thought to chew on. In this new era of microservices, serverless functions, and containers, where being small and fast is king, does the future belong to these lightweight, direct control frameworks, or will the all-in-one giants continue to rule? It's a really interesting question, and one that just might define the next wave of back-end development.